Introduction for this topic is analysis about rock slope to extend or undergo movement using UAV technology and remote sensing. Rock slopes are susceptible to instability problem due to various factors, both in the rock mass condition and external factor from the environment. The material of the slope is slope height, slope face angle, and discontinuities orientation, which is important role in affecting the stability of rock slope. Road slope analysis involves the use of high-resolution digital stereophotograph from which a 3D image of the slope is constructed using specialized software. This study aimed to analyze the road slope stability forensic based on UAV remote sensing and resistivity. Definition: Slope stability analysis is static or dynamic, analytical, and empirical method to evaluate the stability of earth and rockfill dams, embankments, a vacant slope, and natural slope in soil and rock. Slope stability refers to the condition of inclined soil or rock slope to withstand or undergo movement. The stability of the rock slope can be identified by numerous variables, where the elements such as vegetation coverage and water content are the major contributors. The stability condition of slope is a subject of study and research in soil mechanics, geotechnical engineering, and engineering geology. Analyses are generally aimed at understanding the cause of an occurred slope failure and the factor that can potentially trigger a slope movement, resulting in a landslide, as well as preventing the initiation of such movement, slowing it down, or arresting it through mitigation countermeasure. An unmanned aerial vehicle or UAV with a camera mount on it used to obtain photogrammetric data. The photogrammetry approach is used widely in geomorphological environment and road slope mapping for discontinuity characterization. UAV image can produce a slope map of the real site study area with highly accurate result. With the output from the photogrammetric process, the rock outcrop can be seen clearly with its geological plan. The data extraction from the geological plan is very important as it is one of the main input for the rock slope stability analysis. An aerial survey using UAV such as drones can provide a fast and efficient method to capture data over large areas in a short amount of time. The use of drone for inspection survey provides safer access to assets that are hazardous, dangerous, or hard difficult to access such as high-rise building.
Development of technology. First, strategic UAV can grow in size for greater payload capacity, reliability, and endurance. Second is tactical UAV will evolve toward a multi-role, multi-mission platform. The third is micro UAV is military and law enforcement utility. Next is vertical take-off landing UAV provide a small, highly maneuverable platform to conduct overhead surveillance, remote sensing, communication relay, and ultimately surveillance. Next is unmanned combat air vehicle. And the last one is key elements in network-centric warfare have widespread deployment of a variety of UAV include data, function, and management. The objective is first to understand the use of UAV remote sensing method for rock stability forensic. Second objective is to describe the use of instrument, hardware, and software. The third objective is to state the work of rock slope stability forensic based on UAV remote sensing and resistivity.
Now is theory and concept. Firstly, on rock slope stability. Generally, the analysis on rock slope stability are involved in determining the causes on how rock failure occurs or the factors that likely lead to a rock slope movement, which resulting a landslide at certain areas. These rock slope failures are classified into these four types of rock slope failures, which the first one, planar failures, which are occurred by a single discontinuity surface dipping out of a rock slope surface. Second, wedge failures, which involve a failure mass occurred by two different discontinuity with a line of intersection that incline out of the rock slope surface. Third is topping failures, which involve some column from rock that discontinuity aligns steeply into the rock slope surface. And lastly is circular failures occurs when inside the rock masses are either highly composed of material with low intact strength. Rock slope stability can be determined by these factors, which concern the angle of the slope and the strength of the material on it. As the three figure below, for figure A, the shear force is substantially less than the shear strength, so the block should be stable. For figure B, the shear force and shear strength are about equal, so the block may or may not move. For the figure C, the shear force is substantially greater than the shear strength, so the block is very likely to move. Second, for UAV remote sensing, the unmanned aerial vehicle or UAV typically operate using a remote control which is connected to a device that can display the drone flight data and transmitting live image from the camera aircraft in real time. By using UAV, it involves the use of HD digital stereo photograph from which a 3D image of the rock slope can be constructed. Such images can be highlight the surface texture of the rock slope and identify the potentially unstable zone. As for the figure above, it is a drone called octocopter in flight carrying a DSLR camera. Okay, third, for resistivity. Electrical resistivity is an ideal method to minimize the destruction on soil compared to other tests such as drilling and penetration tests. The soil profile of resistivity image was then compared to borehole profile, and the relationship between the resistivity value and the properties of soil were developed. As the figure below, it shows that the subsurface consists of low resistivity value with below 200 ohm meter, interpreted as low stiffness or loose soil. The blue color is due to soil having high moisture content that reduce the resistivity value. This is the area where the slope failure was occurred.
Conventional slope monitoring system. Conventionals mean a normal slope monitoring system. There are four. One is the theodolite. Theodolite is to measure the angle between horizontal or vertical planes. And right now there are two types, which are digital and non-digital. But for nowadays, most of people use digitals. The second is total station. Inside the total station, it consists of electronic distance meter, which is EDM. It had electronic theodolite. Third, it had onboard microprocessors, data collector, and data storage. The function of total station is to measure bearing or angle, distance, and slope distance. Crack meter. The function of crack meter is to measure the displacement across the crack or joints that is found in building, bridge, pipeline, and rocks. It is an ideal tool for monitoring the movement of building structures, and secondly is to monitor the progress of the surface crack in structural component and building that caused by subsidence or mechanical failure. Unmanned aerial vehicles or UAV, it commonly known as a drone. It is an aircraft without any human pilots or crew or passenger on the aircraft. UAV are a component of Unmanned Aerial System or UAS, which include additional ground-based controller and a system of communications with the UAV. Automatic deformation system. In automatic deformation system, it consists of inclinometers and extensometers. Inclinometers is also known as clinometers. Is an instrument for measuring the angle of slopes of tilts and elevations or depression of an object with respect to gravity directions. So the outcome of a measurement is angular measurement, which is degree, minutes, and second, or percentage. Extensometers is a device that is used to measure change in length of an object. It's useful for tools that are stretch strength measurement and tensile tests. Its name comes from extension meters. It consists of two types of extensometer, which are contact and non-contact. Contact type, there are click-on extensometers and automated testing click-on device. For non-contact extensometers, it had device extensometer and laser extensometers. Real-time monitoring systems. Real-time monitoring system means it can monitoring a place for 24 hours. There is slope stability radar and movement and surveying radar. Slope stability radar or SSR is to remotely scan a road slope and to continuously monitoring the spatial deformation movement of the locations. It can detect the deformation movement of a road wall with high accuracy and high spatial and temporal resolutions. It gives us a full area coverage with another equipment. Its radar wave can penetrate through rain, dust, and smoke. Movement and Surveying Radar (MSR) is a system that intended to monitor mine slope to detect the movement and generate a warning of close failure so that equipment may be removed before failure occurs. The elements in MSR provide very accurate, real-time, and all-weather slope movement measurement with a good detection ability, and it's able to provide an alarm if it detects movement reach a predetermined levels, thereby permitting evacuation of the unstable area and enhancing safety. Hardware. In UAV, there are some components or hardware to let it work coordinately. In UAV, it contains three main components which are area platform, ground control stations, and communication system. The area platform. The area platform contains airframe, navigation system, power system, and payloads. Airframe is the whole body of UAV that will contain all the hardware and software. Navigation system, it has GNSS and INS. It will provide a reliable source of the navigation information that can be used by UAV, autopilot, or other system. Power systems is like a battery. It's a basic need of UAV to generate powers. Payload is a sensor that carried by UAV to use to acquire some specific data or parameter like multispectral camera or video camera. Ground control stations. Ground control station is a very important and mandatory component. It's for us to work in safe conditions and to verify in real time the operating state, which is the temperature of the battery or the state of the power of the UAV during the flight. The communication system is an important hardware to UAV because it remotely controls. The communication system will provide the communication between the area platform and ground control stations. One uses frequency to control UAV from the ground via remotely pilot, while other to ping data to first-person view video. For the communication system, it consists of satellite, radio signals, and internet.
Okay, for the software, we can use DIPS. DIPS is Stereographic Projection Program for analysis and presentation of orientation-based data. DIPS also analysis and visualize structured data following the same technique used in manual StereoNets. The second software is StereoNets, can carry out simple slope stability analysis for planar or wet failure on the rock slope. And the third software is Geo5 Rock Stability. The program is fast and reliable optimization.
Type of the data. Type of data include the aerial photograph and LiDAR imagery. Figure 1 show the using a UAV photogrammetry to measure and collect the structural plan information. And figure 2 is A is the photograph of the valiant rock mass, and B is a resulting LiDAR model of the potentially unstable rock fall zone.
Next, methodology of work. The method for this work is first, planning of work, contain UAV preparation. Second, process of work and data. It concludes UAV measurement, precision digital modeling, bundle adjustment method, and measurement accuracy. Lastly, accuracy and analysis. Slope stability analysis, block stability analysis, structural plan identification on random sample consensus, and identification of key blocks.
Planning of work. Before starting the road slope stability, we need to have an image to start it. So we need to make a flight planning and UAV preparation. The planning of the flight is for us to make sure some of the work can be prepared before starting the flight. So it will run smoothly. Flight planning was done by deciding the pattern or route of the UAV, height and overlap. The route of the UAV, also known as nadir line. We'll be using a grid mission as a pattern for us to snap the image of the area. We also need to establish control point, or it also known as ground control point (GCP). Ground control point contain coordination for us, so it'll be easy for us to combine all of the image. UAV preparations. In UAV preparations, we need to set the height of the UAV so that it will have an accurate distance of the image. UAV will fly at the same height and follow the pattern that we have planned in the flight planning, which is nadir line. In UAV preparations, it also contains of camera orientations. Camera orientation, it has true vertical photograph and near vertical photograph and oblique photograph. True vertical photograph means that it's 90 degrees from the ground. Near vertical photograph, it is almost 90 degrees. Oblique photograph, it contains of two, which is high oblique and low oblique. Oblique photograph is for us to take pictures for see the large area. High oblique and low oblique, the difference is that in high oblique that we can see the horizon. In the pictures, we can see that the flight is flying at the same height. It will also follow the nadir line. And when it taking the image, we need to make sure that it had a 60% of overlap between photos and 20 to 40% of overlap between flight line.
Next, I will explain about process of work and data. First, UAV measurement. Using low-altitude UAV aerial photograph to obtain remote sensing image has many advantages. First, small influence of the weather. Second, lower cost. And third, provide high-quality image. 4-axial UAV was used to map the rock surface and to acquiring the coordinate of the point cloud. With a ground station system, the UAV can be controlled easily and efficiently. Second, precise digital modeling. There are three main parts or steps of the whole system. First, data pre-processing. In this stage, all the data, rock surface image, summarized and combined together. Bundle adjustment. The bundle adjustment is used to determine the spatial position of the pixel point. The sparse point cloud is formed by this 3D space pixel point. And third, 3D modeling. The shape of the surface was determined by the control point to generate the non-uniform rational basis spline surface. A 3D spatial model was established by using surface data and texture data. This is the flowchart of 3D modeling procedure based on UAV tools. Third, bundle adjustment. Collinear equation is basic formula for the advanced bundle adjustment. The basic unit is the bundle corresponding for each picture and using the position transform of each bundle. we achieve the intersection between the bundle of the same point. External azimuth element of each picture will get after the adjustment calculation done. The approximate value of the external azimuth element and the ground coordinate of each picture will calculate. Then we use the collinear equation to list the error equation of the control point and the encryption point. The first equation is for the collinear equation, and the second is the error equation.
In process of data, we have measurement accuracy method. To verify the accuracy of the 3D model, a case study was carried out. The scale of the test slope is 473 meters times 208 meters, which was calculated by using 170 photos in different shooting angles. The error can be calculated using calculation below. Okay, next is the graph shows the measuring error calculated using the calculation above. It can be seen from the graph that the overall deviation at the GCP is less than 0.8%, suggesting it is acceptable range. Then, to identify the ransack method in real rock mass structure plan research, a partial part of the slope model was used, and then the table of total 9 typically structured plane were identified from the model. To inspect accuracy, the data of deep angle and deep direction was compared. The identification result showed that the error and the deviation of the deep direction and deep angle are in a small scale and close to the actual situation. As the figure down below, at the right side show the table of comparison of structural plane measured inside generated by ransack method, while at the left side shows the figure of characteristic structural plane identification of 3D terrace model built with point clouds by ransack method.
Accuracy and analysis. The image is the wedge failure. A rock may slide over two intersecting discontinuities as a result of this form of failure. At least one joint intersection must have the tip angle larger than the joint surface angle, a fraction for this mode of the failure to occur. Inclinal bending, foliation, and well-defined cleavages are all the good lithology for the formation of the wedge failure. Shell limestone and slag are some of the most common type of the rock. However, for wedge failure to propagate, specific structural conditions also required. The following are the requirements. First is the intersection plot lines should be higher than the slope fraction angle. The second is on the slope, the intersection line should dead line. This means that the intersection stick angle should be less than the slope stick angle. Analysis of the wedge block. Block theory study include the block cutting theory. This four figure is the decomposition and merging of the block. A is the decomposition circuit include the P1, P2, P3, P4, and P5. B is the shape and position of the plane PI include the P1, P2, P3, P4, and P5. C is a larger view of the portion of the modeling domain containing PI, and D is the merging of the plane. Block stability analysis. The single-side slipping model and the double-side slide model are two most common failure model for block system. The picture is the single-side sliding model. A is show the failure model with single sliding surface. B is a process ending on single sliding block. C is show the failure model with two sliding surfaces. D is a process ending or double sliding block. Equation single-side sliding model. The first equation is the anti-slicing forces and sliding forces ratio. Equation can be used to calculate the safety factor Fs. And second equation is the equation to calculate the energy for a block. G is the gravity of the block. C is the cohesion of the structure. S is the area of the sliding plane. And vector is the internal fraction angle of the structure. And theta is the D angle of the sloping plane. Alpha is the inclination of the structure, and beta is the depth of the structure. Double-side slide model. Two sliding surfaces will make the simultaneous contact with the rod in the sliding mechanism. Figures show the breakdown of the block B on the click face. Equation double-side slide model. The first equation is the safety factor of the two-side sliding model. Fs can be defined as an equation. The second equation is the equation to calculate the energy of the model. The third equation is to calculate the volume of the block. Structural plan identification of random sample consistency. To construct a slope model, we use the random sample consistency approach to recognize the structural plans. The entire slope has a total of 491 structural plans. Figures show the structural plan identification of the resi of the rock clip face. Figure A shows the roadmap of all the structural plans. Figure B shows the stereographic projection and density of the structural plans in three groups. Three good structural planes have the dip direction of 276.3 degree, 297.5 degree, and 69.8 degree. The dip angle of the three structural planes are the 56.7 degree, 88.4 degree, and 86.7 degree. The degree of the dispersion of the first and second group is much smaller than the third group, as shown as the joint density map B. The dip angle dispersion is substantially less than the dip direction according to the finding. Identification of the key block. Following the acquisition of the structural plan information, the stability of the rock mass was investigated using the GeoSMA 3D technology. The rock structural property, non-linearity, inhomogeneity, and anisotropy may be replicated within the GeoSMA 3D program using the block theory and limited equilibrium criteria. A figure shows the click face rock slope model generated by GeoSMA 3D.
For the conclusion, evaluation on stability of rock slope is a prime, interesting and formidable aspect in environment issues. The combination of UAV photogrammetry and computer implementation can produce 3D modeling for rock stability. The recommendation in future is more addition function should be developed, including surface plane identification, curve block stability analysis, the water pressure, seismic issue and seepage effect on the point rock slope.